All right. Hi, everyone. Thank you so much for joining the stream. So today we'll be discussing about an introduction to data structures and algorithms, specifically the topics that we know which are relevant for the coding interviews. So that is what we'll be discussing today. So basically, as you guys already may be knowing the importance of data structures and algorithms when it comes to the interviews. So preparing for that is really, really important. And so a roadmap of how you can prepare that is not what we'll be doing today. What I will give you a review of today is, the basic data structures or the important algorithms that you need to go through on your journey when it comes to data structures and algorithms will be what we'll be discussing today. All right. So whatever we discuss, any doubts that you guys will be having, we will be having a Q&A session in the end. So in the beginning, I will be giving an overview of the important data structures and algorithms that you have, just a brief info so that you guys are aware of how you can start your DSA journey and how you can go ahead with it. And yeah, that's all what we'll be doing. So I'll quickly share my screen. So just give me a minute. Oh, all right. There was a glitch, I suppose. Just a minute. I'll quickly begin. All right. So let us start with this introduction to data structures and algorithms. So first of all, the question arises, what are data structures? Why are they important? And what do they do? Right. So when we first talk about data structures, the first question comes to our mind that comes to our mind is like, why do we need them? What are we doing with it? So the first or the most simplest thing that you are doing with the help of a data structure is that you're simply storing the data somewhere, right? So whatever data you have, whatever data is generated from your system. So, let's say you have an e-commerce website. Let's say you are shopping at Amazon or Flipkart or anywhere. You're just doing online shopping. So at those places, a lot of data gets generated, right? As a user, you will be first logging into your Amazon or Flipkart account, whatever it is. Now, once you log in, the next thing that you do is you may be adding some items to your shopping cart, and then you will be purchasing the orders, right? Now, throughout this journey, a lot has happened. First of all, you as a user has registered, so that is a piece of data that you have contributed. The next thing that you do is you added some item into your cart, so that is another piece of data that you generated. Now, of the items that you have added into your cart, let's say one of the items, you go ahead and you buy those items, so you have generated an order as well, right? And then you do the payment, so there's a payment ID as well that you have generated. So on a simple journey of a user purchasing a single item from an e-commerce website, a lot has happened and a lot of data has generated, right? Now there, sure. Now what do we need from our side is a place where I can keep all of that data, right? So there, that is where a data structure comes in. So a data structure, the most simplest thing that a data structure does is to store a particular piece of data, right? Now, storing, as a simple example, is not something what we desire a data structure to do. Storing is a very simple thing which someone else could have also done, right? But the point is, when we talk about a data structure, storing may be something, but when you need to get that data out, or when you need to put your data into that data structure, is something which is important, right? So let's say I am performing an operation in which I access the topmost elements very frequently, and I don't need the bottom ones, right? So I need only the latest data. So there may be a data structure which would help me more. Let's say if I have a use case where I need, the data which was stored first, I need that data to come out first. So that is a different data structure that I should deal with, right? So when we talk about different data structures, they serve different use cases to us. Storing is something which any one of them can do. The most important thing is how data is organized inside a data structure, right? So a data structure is something which is able to store the data that you give it, plus organize the data, and whenever you want to access that data, it should be done efficiently depending on your use case. So we've got these 3 points, that first of all, a data structure is for us to do the storage. Second thing that we need is the data structure is with us to access that data efficiently. And the third thing is whenever you want to manipulate the data, you want to change something with the data, then again you have the data structure coming into play. All right. So storage is not something which the data structure does alone, but the most important thing is how efficiently you can access the data depending upon the use case you have. All right. So depending upon the different use cases that you may be having, a different data structure may be incorporated in that case, right? So depending on that, there are different types of data structures. The most important ones, we'll be discussing them today. I'll be giving you guys a brief info about that, because when we talk about data structures, it's not something which can be covered in like 25 or 30 minutes. But I'll try to give you guys a brief info so that from where you should take it, right? So that whenever you are practicing or going ahead, it is something which is very clear to you, right? All right, let's go ahead and now let's discuss the types of data structures one by one. So first of all, the simplest one are the arrays. So when we talk about an array is like a simple list of items, right? Where you have different items stored one after the other. And when we talk about the memory locations, so let's say you have your computer, and inside your computer you have memory, right? Now with that memory, you have different locations. Let's say location number one, location number two, location number three, location number four. So, you can relate this with the your the society or the community in which you may be living. So there, what you have is you have different houses placed one after the other, right? So address number one has house number one, address number two has house number two, address number three has house number three. That is similar to how an array stores the data. Data at contiguous locations or continuous locations are stored one by one. All right. So the first data point will come at address one. Second data point will come at address two. Right. Now this contiguous memory location that array has helps it to access the different elements which are there in the array very much frequently, or the fast access is an advantage in this case. So because even if you know wherever the first element is stored, if I tell you, okay, get me the address of the fourth element, so if first element is stored at address number one, the fourth element will be stored at address number four. Likewise, if you need the address of the 10th element, it will be stored at the 10th location. Similarly for 15th, 20th. So the access is very fast. You don't need someone else. If I tell you, okay, this is the location of the first element, you can quickly figure out what is the location of the 10th element or whichever element you need. That is the greatest advantage of why you will be using array many of the times. Okay, so whenever you need fast access, you need to quickly access the element. If I tell you, okay, get me the fifth element, if you want to get me the fifth element, you'll tell, okay, if you just use an array, and you can quickly get the access because it provides you random access, right? And that is what we call indexing. So if we go ahead, so if you look here, these are the array elements, right? So on the first location, you have number one stored. On the second location, you have number four stored. You have on the third location, you have number three stored. So if you see, these are ordered. So 0, 1, 2, 3, 4, they are the locations or the indexes. Okay, so if I tell you that, okay, the fourth element is 8, I want to get the fourth element, give me the address of the fourth element. So you'll tell me that, okay, hey, the address of the first element is 0. So if you want to go to the third element after the first element, you will do 0 plus 3 and you get the address 3. And if you can quickly go to the address 3 and you can access 8. Okay, so that's why an array is really important when it comes to random access. It can quickly give you the element, you can take it out, and that is something which is really important in this case, right? Now, with this advantage, there are also many disadvantages that an array has. Okay, so let's say if you want to delete a particular element, let's say you need to delete the element 8. So if you want to delete the element 8, you cannot just simply delete it. You have to follow the rules which you had obeyed, right? Because we have to store the elements at contiguous locations. So you have to fix that up, right? Now, whenever you delete an element in the middle of the array, let's say you delete the number 8. If you delete 8, you have to move the 4, which is on the right, to the position where 8 is located. Similarly, you have to move the 9 in place of 4, 2 in place of 9, 5 in place of 2, and 6 in place of 5. Okay, so you have to do that extra effort of shifting each and every element to its left to cover up the space, right? Now, this operation is a little bit costly, and that is what you have to pay when you need fast access, right? So that is what we deal throughout the data structures. We will do a trade-off. If you are doing a trade-off on one operation, then you have to compromise on the other operation. So if one thing is providing you a faster access, the other thing might take away from you, the ability to quickly remove an element or to add an element. All right. So that is what happens in case of an array. Now let's go ahead. Another data structure that we have is linked lists. Okay. Now linked list is very similar to the array. There's only one thing which is different is you cannot random access the element. If I give you the address of the first element, you cannot immediately get the address of the fourth or fifth element as you are doing in case of array, because this time the elements are not stored one after the other. The address can be completely different. Let's say the first item that I have, it may be stored in address number 1, but the second item may be stored in address number 4, third can be stored in address number 50, fourth can be stored in address number 2. So it is all scattered. Okay, there's no ordering of the addresses, so you cannot do fast access, right? So what happens in case of a linked list is, if I give you the address of the first element or the first node, so the elements, we also refer to them as the nodes. So if I give you the address of the first node, you can only go to the second node and not any other node, because each node in a linked list will only contain the address of the next node, right? Then if I give you the address of the second node, you can go to the third node and no other node. If I give you the address of third node, you can go to the fourth node and no other node, right? So let's say you want to access the 10th element of a linked list. So what happens in case of the 10th element? You first have the address of the first element. Now, first will give you the address of the second, second will give you the address of the third, third will give you the address of the fourth, and so on. You go on till the 10th element that you have in the linked list, right? So that is how you follow this link that is there in the continuous elements that we have, and you cannot randomly access any elements, right? So in this case, what happens is, whenever you want to access, that is slow. But whenever you want to do any insertion or deletion, that will be fast, because this time you don't have to shift the different items that you have, right? So that is a difference that we have. So to give you an example, if you see this figure, first of all, you have the first node. So head is where head is something which points to the first node. So on the left, there are here in this figure, you have 3 nodes, right? Now, each node that you see here, it is divided into 2 parts. First part will keep the data. Data is whatever thing or whatever number you want to store. Okay, so let's say in the array, you were storing number 1, number 4, number 8, like that. So in case of a linked list, in the data field, you can keep that number 1, number 2. Now, this next part that you see here, that will contain the address of the next node. Okay, so the first node that you see has 2 parts, data and next. Data is where you keep the data 1, 2, 4, or whatever thing you want to store. Okay, similar in case of an array. In the next field that you see here, you will store the address of the next node, which will tell you that, okay, if you want to go to the second node, just take the address that I am writing to you and just go there, you will get the second node. Now, once you get to the second node, you have the data at a similar position, and the next field that you see here, this will give you the address of the next node that you have. Okay, so you have to follow this link if you want to go forward, right? Now, in this case, as I told, you cannot randomly access any elements, because you don't have the address randomly, right? If you want the address of a particular element, you have to go to the previous element. Then that previous element will get its address from its previous element, and so on. You have to go to the first element, right? So you cannot randomly access any particular node that you have when it comes to a linked list. Okay, but in this case, you get the advantage of insertion or deletion. So let's say we need to delete this middle node. So when I delete this middle node, I don't have to do any extra effort of shifting elements. I can simply change these pointers. Okay. That is, if I delete the second node, I will simply make the next pointer of the first node to point at the third node, and that's all. So insertion and deletion is very easy in this case, but I don't have random access. So again, as I told you guys, you have to perform a trade-off. If you're not getting random access, you will get fast insertion, fast deletion. But if you are getting slow insertion, slow deletion, then you might get random access. Okay, so you have to compromise based on your use case. So let's say if you have a use case which tells that, hey, I need to perform fast insertion and deletion, but I'm ready to compromise on the random access part, right? So in that case, you'll tell, okay, just go for Ling List. But let's say you have a use case where you say, I can compromise on the insertion and deletion because I will not be deleting many elements. So it's all right for me to, just quickly get the elements, and insertion deletion is fine. I'm not doing it that much, right? So in that point, I'll tell you, just go with the array because this is something you can do in an efficient manner with the help of an array, right? So whatever be your use case, you will come up with a data structure based on that, right? Now let's go ahead. Next data structures are stacks and queues. So these are different data structures, but quite similar in their use case. All right, so first let us look what a stack does. So you guys have heard about a stack of books, or anything stacked on top of each other. So anything that you keep on top of each other, be it some kind of pages, be it some kind of books, some kind of items, which are kept on top of one another. Okay, so let's say you have a book, you keep another book on top of it, then you keep another book on top of it, then you keep another book on top of it. So you get a stack. Okay, so that is how a stack stores an element. So first of all, it will store one element. Then if you tell that, okay, hey, store the second element, so it will store the second element on top of the first element. Then if you give it the third element, it will store the third element on top of the second element. Then if you give it the fourth element, it will store the fourth element on top of the third element. So like this, it stores all the elements that you give it. Okay. Now what happens in case of a stack is, now if you imagine, when you have a stack of books, if I tell you to give me the second book, or let's say if I tell you to get me the fifth book from the top. Okay. So if you simply pull the fifth book, all of the books which are kept above, they will fall, right? So the correct way of taking out the books is, you will take the first book out, then the second book out, then the third book out, then the fourth book out, and then you can take the fifth book out and give it to me, right? So what this means is, when you have a stack data structure, in that case, you cannot directly take an element off. You first have to get the element which is on top of that particular element out, and only then you can proceed, in moving this particular element out of the stack. So whenever you want to perform a deletion in case of stack, the topmost element will come out first. All right. So this operation is called pop. So if you see this figure, when you are doing pop operation, you can only take out 4, which is the top element here, right? And push is inserting an element. So when you have to insert an element, it will be at the top. So let's say you have to add a new element 5 to the stack, so that you can do from the top of the stack, right? So it will be 1, 2, 3, 4, 5. When you want to remove an element, it will be from the top. If you want to add an element, it will be at the top. So insertion and deletion in case of a stack takes place from the same end. Okay, that is the topmost element. If you want to add an item, just add it to the topmost place. If you want to remove an item, just remove it from the topmost place. That's all. You cannot do anything else, right? That's why a stack is called LIFO, which means last in, first out. Whichever goes in last will be the one to come out first. Okay, that is the topmost element. So that is what happens in case of a stack data structure. Now let's go ahead. Next is what we have, queue. So queue is the simple queues that you observe, just a simple line. So let's say there are candidates who are queuing up for a job interview and they are waiting in a particular line. So the first candidate who's there in the queue will get the interview first. The last element which is there in the queue will get the interview last. Okay. You can also relate this to, let's say you went to watch a movie and you went there to at the ticket counter to get a ticket for you, right? Now, when you go to the ticket counter, there may be a queue at the ticket counter, right? So the person who's standing first will get the movie ticket first, and the person who's there at last in the queue will get the movie ticket last. What this means is, when you have a queue, whoever is the first element of the queue, who went into the queue first, will be the first one to take out. Okay, and whenever an item is being added to the queue, it will be from the back end the rare end of the queue. Okay, just related to a simple line or that movie ticket line that you have. Okay, whenever someone wants to enter that queue, that is from the last or from the backward end, right? If someone wants to come out of the queue after their work is done, so they will the first, whoever is the first will get their work done, and then they will come out of the queue. All right, so that is how this will take place. Now, okay, so if you look here, you have two ends in a queue. You have a front end that where the first element lies, and you have the rear end where the last element lies. Whenever you want to take an element out of the queue, it will be from the front end. Okay. Whenever you want to insert an element into the queue, it will be from a rear end. So insertion is similar to the stack, that is from the backwards end. But the deletion that you do, that is on the opposite end or the first end. So whoever enters first in the queue will be the one to step in out first from the queue. So insertion in a queue is called NQ operation, and deletion in a queue is called DQ operation. So if you see, if you want to insert the items, you will do NQ. So first item is 10, so NQ 10. Second item is 8, so NQ 8. Third is 12, 16, 9, 20, 18. Okay, so in this order, you can NQ. But when you want to DQ, you have to do it in the same order. So if you observe the same order in which we did the NQ, only in the same order we can do the DQ operation because it's a queue. All right, first in, first out. Whoever goes in first will be the first one to come out. All right, so let's go ahead. Yeah, so these were some of the basic data structures or the linear data structures. So when I say linear, what I mean is, if you see in all the previous data structures that we discussed, that is, the arrays, the linked list, or be it the stacks or queues, the elements were stored in a line, okay, one after the other, like that. Not necessarily on the same address, but they were stored in a line. So these are called linear data structures. Right. Now, the next data structure that we come across is the trees. Okay. Now, trees are kind of the complex data structures or the advanced data structures that we have. Okay. Now, trees are similar to the normal trees that you know, but they are a bit different from what you already know. Right. So this is how a tree looks. Okay. So before you freak out, I'll tell what this notion and all this functionality means. Just stay with me. Okay. So when you talk about a tree, you see the topmost element. Okay, so the topmost element that you see here, that is P, that is called the root element. All right. So the root element of the tree that you have is the element where the tree starts. Okay. So you have these now, all these elements that you see here, they are called nodes, similar to the case that we discussed in case of a linked list. Okay. So this is the root node. Then you have all the other nodes. Okay. So P, Q, R, A, B, C, D, L, E, F, G, all these are nodes. And the lines which are connecting these nodes, they are called edges. Okay. So the topmost node that you see, it is called the root node. Okay. And what happens is trees follow a parent-child relationship. Okay. So let's say, to give you an example, P is the parent of Q and R. Q is the parent of A and B. R is the parent of C and D. Similarly, A and B are the children of Q, C and D are the children of R. So this is a parent-child relationship. Each node that you see here has a parent except the root node, okay, because there's no node on top of the root node. So every node that you see here has a parent, okay. So you have nodes, you have edges which are connecting the nodes. The topmost node is called the root, and these and all others are the parents and their corresponding children that you have. Okay, so any node, if a node which is any node which is on top or connected to that particular node will be its parent. Okay, and the other node will be its child. Okay, the parent's child. Now, if you look here, there are some terminal nodes that you are able to see here, right? The nodes which are on the last layer. So in this case, you have E, F, G, H, I, or node B or node D. What I mean by terminal is it has no children. Okay, zero children. So any if a node has no children, if the node is not a parent to any of the children, then in that case the node is called a leaf node. Okay. For example, node B. Node B does not have any children, so it is a leaf node. Node D also does not have a children, it is a leaf node. Similarly, E, F, G, H, I, they are all leaf nodes. All right. So that is how a tree looks like. And if you want to store data in a hierarchical fashion, there will be use case that you will be encountering where this kind of notion might help you. So you will incorporate a tree data structure. All right. So this is how a tree looks like. All right, let's go ahead. The next data structure that we have here is graphs. All right. So when we talk about graphs, a graph is something which is very similar to a tree. But what happened was in case of tree, you had that parent-child relationship, right? But in case of graph, you don't have those. Now, what happened in case of tree is, if you look here, so basically, if two nodes in a tree, they have the same parent, so they are called siblings. Okay, like brothers and sisters. Okay, so, like in real life, also, if two people have the same parents, they are called siblings. In a similar fashion, if there are two nodes and they have the same parent in a tree, they are called siblings. Now, if you look here, only a node is connected to its parent or its child. There are no other connections, right? Specifically, siblings cannot be connected when it comes to trees. Okay, but that is not a restriction in case of graphs. You can connect any node to any other node. Okay, so a graph is very similar to a tree, but there are no such rules that you cannot connect this node to that node. So there are no such restrictions. So if you look at a graph, this is how a graph looks like. There is no parent-child relationship. You can just connect the nodes, with each other, and there's no harm in that. All right. Now, graphs are of two types: directed graphs and undirected graphs. So, in case of directed graph, you see these arrows, right? So, what these arrow means is when you are traveling inside the graph, you can. So, let's say in this example, 1 and 0 has an arrow where the arrow from 1 goes to 0. So, this means that if you are at node 1, you can go to node 0, but from node 0, you cannot come back if the graph is directed. Similarly, in case of this directed graph, there is a directed edge from node number 2 to node number 1. This means that if you are at node number 2, you can go to node number 1, but the converse is not true. That is, if you are at node number 1, you cannot directly go to node number 2. You may need to take another path if it exists. All right, so there is this restriction which we have in directed graph. But in case of undirected graph, you don't have any such restriction. Let's say there is an edge between node number 1 and node number 2 in this undirected graph that we see. So you can go from 1 to 2 and come back from 2 to 1 directly, right? There's no harm. So these are the two different graphs that we have. All right. Then, yeah, so basically these were some of the data structures. There's one more, I guess. Yeah. So another one and a very, very important data structure is hash tables. Okay. Now, hash table is a very simple data structure, not at all complex, very simple. It is simply key value pairs and nothing else. Okay. So you have a key, and corresponding to that key, you have a value. Okay. So if you say that, okay, hey, if you go to a hash table and you say, hey, I have this key, can you give me the corresponding value? It will tell you, okay, just give me the key, I will give you the value. Okay, like the value is like a lock, and the key is the key that you have to open the lock, right? So if you have a key and you got a lock, so you can open that lock with the help of the key, and you get inside the value which you get, right? So if you look here, you have these keys and key value pairs. So let's say you have the names of some people or some users, and you want to store their phone numbers. So let's say you have a person called John Smith. Okay, so John Smith wants to save you want to save their mobile number. So you will keep John Smith as the key, and in the corresponding value, you will just store their phone number. All right. Similarly, this you can do with the other users as well. So any name that I give you, you will create a key with that name, and in the value, you will simply put the phone number, so that whenever someone comes later and tells me, hey, I just got this name, can you fetch me the mobile number or the phone number of that particular person? So the hash table will tell you, okay, just give me the name. I can quickly check it and give the value to you. All right. So this is how the key value relationship helps us, deal with this. So yeah, that's how it works. You have these key value pairs, right? All right, let's go ahead. So these were the most important data structures, and if you get yourself mastered in these data structures, you practice and practice the different questions that you have got in these data structures, then you're really good to go with each and everything that you have. All right, so these were the data structures. Now, since you have got the idea of these data structures, the next thing that you should do is, now I haven't covered completely the theory. I haven't gone into the depths that you say, but I have managed to give you guys the basic idea of the different data structures that you see. Okay, so it will be these data structures that you will be exploring more and practicing more and more, right? Now you are in a condition of starting to practice the different problems that you have got for these data structures. So after this session that I have taken, you can jump to the problems, but not the, not the very advanced ones. You can start with the problems, right? As this was an introduction to the data structures that we have got, right? Now, once we are done with the data structures, the next important thing that we have to discuss are the algorithms, right? So when we talk about algorithms, algorithm is something which will tell me what to do. Okay, so let's say I have any problem I have, or any daily life issue I'm facing, or anything that I want to do. Let's say I want to go to the let's say my friend is not well and I want to go to the pharmacy to get my friend a medicine. Okay, so let's say I have got this work, and to get this work done, there will be some procedure that I'll be following, right? So let's say the procedure can be, okay, I'll take a piece of paper in my hand. I'll write the name of the medicine that my friend needs. The second thing I can do is I'll go to the shop, the pharmacy. That is the second thing. The third thing that I can do is I'll ask the pharmacist to give me the medicine. The pharmacist will give me the medicine. The next thing that I'll do is I'll pay for the medicine that I've taken from the pharmacist. And then the next thing that I'll do is I'll come back to my home and I'll give the medicine to my friend. Okay, so these were some 5 to 6 procedures that you have to follow, okay, or the steps that you have to follow. So this kind of step-by-step procedure for solving a particular problem is called an algorithm. Okay, so whenever I give you a particular problem or anything that you are dealing with, so first of all, just making sure that you have all the step-by-step procedures is what you tell constructing an algorithm. So whenever you want to come up with the algorithm, if I tell you, give me algorithm for doing this, I mean, I want a step-by-step procedure of how to do this. Okay, any task that is given to you, a step-by-step procedure of how to accomplish that particular task is what we call the algorithm. All right. Now, once we know what are algorithms, let us look at some of the important algorithms that you will be encountering, right? So first of all, we have the different sorting algorithms. Now, when I say sorting, there are different types of sorting algorithms. So when I say sorting, I just mean to, if you have something jumbled, I just want you to put them in order, right? So let's say you have these four letters jumbled, let's say B, D, A, and C. So I just want you to put the four of these in order, like A, B, C, or D. Okay, so in that manner. So any number of items that I give you, which are jumbled or may not be, or be completely random, they may not be at a proper place with respect to each other. If I tell you to sort them, I mean to, place them in order. So let's say you have got an array, and in that array, you have elements jumbled. Okay, so let's say 46, 2, 53, 7, 9, then 4. So like this, you have jumbled. If I tell you to sort the array, what I mean is I want the elements to be ordered like 1, 2, 3, 4, 5, 6, depending upon whatever items are there. So to do this, there are different types of sorting algorithms that you have encountered. There is bubble sort, there is insertion sort, there is merge sort, there is quick sort. So depending upon how much time they take and how much efficient they are, different sorting algorithms are used for different purposes, right? So you'll encounter different sorting algorithms. We won't be discussing each of them in much detail. I just wanted to give you guys an idea of what sorting algorithms are. Now let's go ahead. Next thing is the searching algorithms. Okay, so sorting is one thing. Now let's say I give you a particular data structure. Let's say you have an array, right? Now I tell you that, okay, in my array I have stored the, let's say, the marks of the students who are studying in my class. Okay, let's say the marks for mathematics of the students who are studying in my class. Now I want you to check whether a student has got let's say 90 marks in the exam. Okay, so and all the marks are stored in the array. So what I'll tell you is, go search the array and tell me whether there is an element which has the value 90. Okay, so this is called searching. Now when we talk about searching, so there are different techniques in which you can do the searching. So the first thing and the most basic thing that comes to the mind of any person is, I'll start from the first element. I'll check each and every element in the array. If I get 90, I'll tell that, okay, hey, I just got 90, and yeah, there is an element with a value of 90, and I got that. Okay, so that is the simplest thing that you can do. Okay, so this simplest thing that you have done, this is called linear search. Okay, so when you say you're doing a linear search, you are simply iterating or moving through each and every element that you have in any data structure that you use. In this case, you see an array. So let's say you are here to search the element 5 in the array. Okay, so you start from the first element, that is 10. So let's say you started from 10. You went to 10. You said, okay, this is not 5. Then you go to the next element. It is 8. You say, hey, this is not 5. Then you keep going until you find 5. Okay, so once you find 5, you will stop. Okay, so this is linear search, and the most basic search and the most obvious thing that you can do when I tell you to search something. All right. But the difficult part is, let's say I give you a million or billion elements, then what you will do is, if you start from the first element, and let's say if the element that you are searching for, let's say it's at the last position. So you will waste a lot of time searching for that element, right? So this makes us feel that, okay, this approach that we have taken, this is not at all smart, right? So to get to a smarter approach, there's another searching algorithm which is called binary search, right? So when we talk about binary search, it is kind of a smarter way to search a particular item in the array. So let's say you start with the, in this case, what happens is, instead of starting from the first value or the last value, we start from the middle value, and we keep eliminating half of the array in each move. Okay, so let's say if you are searching for 27, if you start with 27, and let's say you are searching for a number which is less than 27. So for this case, first of all, you should have a sorted array. Okay, so if you are searching for a smaller element, you will go to the left hand side, and now you will not check the right hand side, right? So this is a smarter way. Similarly, when you search, when you have the remaining part of the array, if it is less than the element which you have in the middle, again you will go to the left hand side, and you will keep ruling out the other half of the array, and this will be done in very less time, right? So this is how a binary search looks like. So these are the two important searching algorithms that you see, and you get to know uh, uh, you get to have lots of questions when it comes to the searching algorithms in your interviews, specifically for binary search. This is a very important topic, right? Now, there are some graph algorithms. Like when we talk about graph algorithms, so you have these algorithms which help you in traversing the graph, or moving around the graph. Let's say you start with a particular node in the graph, and you want to visit all the other nodes, or any, if you want to visit the nodes in a particular fashion. So the graph algorithms come into play, right? So we will not be discussing this, but these are the three important graph algorithms which are very important for when it comes to interviews. Okay, so you have BFS, DFS, and an algorithm called Dijkstra algorithm, which helps you to find the shortest path when it comes to a graph, right? Now, next thing, which is also a very important topic when it comes to the coding interviews, especially for the companies which are high paying, for example, the FANG companies, or similar companies which offer you like a good package. So there you have dynamic programming. Now, when it comes to dynamic programming, what it helps us is, if there is a problem in which I am performing a lots of steps, I am wasting a lot of time. So dynamic programming offers me a way to optimize it by having a trade-off with the storage. Okay, so what dynamic programming says is, let's waste more storage and save us some more time. Okay, so let's say you have an algorithm which was taking some more time in the beginning. If you use dynamic programming, this will help you to delete some of the overlapping steps that you are doing, and it will help you avoid some kind of recomputation, and it will save your time. Okay, so that's why it is a very important programming paradigm, which helps you to deal with such positions where you have to solve a problem which was taking a lot of time, and you want to optimize it, right? So yeah, these were the different important algorithms when it comes to the coding interviews. So you just need to ace all of these topics, and you need to practice questions for each of these. Once you do it, you will be very good when it comes to the DSA part, right? So now let us open the discussion for any questions that you guys may be having. So if you guys have any questions, you can put it in the chat box. I see some of them. Storage can be done by databases. Yeah, databases basically when you say you are storing something in a database, so a database also has a data structure enabled in that. Okay. For example, when you are performing SQL queries or you are creating a normal database that you have, so there is another data structure which is called the disk structure, which is it is a complex data structure, not it is not something which is very important for the coding interviews, and it is an advanced data structure, so that's why I didn't discuss it. But when you talk about a database also has something, which will help you to, efficiently store and manage the data that you want to have there. Okay. All right. We can say, all right. So, any other question that you guys may be having? So we'll wait for another 2, 3 minutes. If anyone has a question, if you guys don't have any questions, then we can end the session. I hope you guys enjoyed to having an introduction about the data structures and algorithms that you should start with and that you need to practice. Uh, so yeah, that's all I got for today. I'll wait for another 2 minutes. If anyone has any doubts, then we can end the session, right? All right, so I don't see anything in here. So let's conclude the session for today. Thank you so much for joining the session, and I hope you guys got to learn something today. So, all right, we'll conclude the session for today. Thank you so much for joining. Bye bye.